and molecules. Learning about atoms and molecules. Sugar, salt, sand, diamond, graphite, copper, silver, gold, iron, aluminium, wood, rocks, minerals, food and clothes are all different kinds of matter. An Indian philosopher, Maharshi Kannad, postulated that if we go on dividing matter, we shall get smaller and smaller particles. Ultimately, a time will come when we shall come across the smallest particles beyond which further division will not be possible. He named these particles Parmanu. For example, if we continue to divide matter, we get to atoms. Try to divide atoms and you get quantum fields. The word atom means indivisible, something which cannot be divided further. The combined form of atoms is called molecules. All matter is made up of small particles called atoms and molecules. Different kinds of atoms and molecules have different properties, due to which different kinds of matter also show different properties. Anthony L. Lavoisier laid the foundation of chemical sciences by establishing two important laws of chemical combination. Laws of chemical combination. The following are two laws of chemical combination. The first law is law of conservation of mass or matter. The second law is law of constant proportions. The first law is law of conservation of mass. The law of conservation of mass means that in a chemical reaction, the total mass of products is equal to the total mass of reactants. There is no change in mass during a chemical reaction. Since there is no gain or loss in mass in a chemical reaction, the mass remains conserved. The total of the reactants and products includes solids, liquids and gases, including air, that are a part of the reaction. The law of conservation of mass will become clear from the following example. When calcium carbonate is heated, a chemical reaction takes place to form calcium oxide and carbon dioxide. It has been found by experiments that if 100 grams of calcium carbonate are decomposed completely, then 56 grams of calcium oxide and 44 grams of carbon dioxide are formed. This can be written as: in this example, calcium carbonate is the reactant and it has a mass of 100 gram. Calcium oxide and carbon dioxide are the products and they have a total mass of 56 gram plus 44 gram comes to 100 grams. Let us perform one activity to study law of conservation. Activity. Take a little amount of sodium carbonate solution of Y in a conical flask. Take a little amount of copper sulfate solution of X in an ignition tube. Hang the ignition tube in the flask carefully and see that the solution do not get mixed. Put a cork on the flask. Weight the flask with its contents carefully. Now tilt and swirl the flask so that the solutions X and Y get mixed. And weigh again. Barium chloride solution reacts with sodium sulfate solution to form a white precipitate of barium sulfate and sodium chloride solution. We again find the mass of the apparatus along with products by weighing on a balance. If we subtract the initial mass of the apparatus from this mass, we will get the mass of products. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Let the whole problem and solution appear on brick screen. Let us solve one problem. Calcium carbonate decomposes on heating to form calcium oxide and carbon dioxide. When 10 gram of calcium carbonate is decomposed completely, then 5.6 gram of calcium oxide is formed. Calculate the mass of carbon dioxide formed. Which law of chemical combination will you use in solving this problem? This problem is to be solved by using the law of conservation of mass in chemical reaction. In this reaction, calcium carbonate is the reactant, whereas calcium oxide and carbon dioxide are products. Now, from the law of conservation of mass, we have mass of products is equal to mass of reactants, or mass of calcium oxide plus mass of carbon dioxide is equal to mass of calcium carbonate. So, putting the value we get, 5.6 plus mass of carbon dioxide is equal to 10. Therefore, mass of carbon dioxide is equal to 10 minus 5.6 is equal to 4.4 gram. Thus, the mass of carbon dioxide formed is 4.4 gram. The second law is law of constant proportions. A chemical compound always consists of the same elements combined together in the same proportion by mass according to law of constant proportions. In a compound such as water, the ratio of the mass of hydrogen to the mass of oxygen is always 1:8, whatever the source of water. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 grams of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 14:3 by mass, whatever the method or the source form which it is obtained. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. He took the name atoms as given by the Greeks and said that the smallest particles of matter are atoms. His theory was based on the laws of chemical combination. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. 1. All matter is made of very tiny particles called atoms. 2. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. 3. Atoms of a given element are identical in mass and chemical properties. 4. Atoms of different elements have different masses and chemical properties. 5. Atoms combine in the ratio of small whole numbers to form compounds. 6. The relative number and kinds of atoms are constant in a given compound. Let the whole problem and solution appear on big screen. And let us solve one problem. Hydrogen and oxygen combine in ratio of 1:8 by mass to form water. What mass of oxygen gas would be required to react completely with 3 gram of hydrogen gas? Now solution. Here, we have been given that hydrogen and oxygen always combine in the fixed ratio of 1:8 by mass. This means that 1 gram of hydrogen gas requires 8 gram of oxygen gas. 3 gram of hydrogen gas requires 8 into 3 gram of oxygen gas. It comes to 24 gram of oxygen gas. Thus, 24 grams of oxygen gas would be required to react completely with 3 grams. Summary. The law of conservation of mass means that in a chemical reaction, the total mass of products is equal to the total mass of reactants. There is no change in mass during a chemical reaction. A chemical compound always consists of the same elements combined together in the same proportion by mass according to law of constant proportions. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. That is all in this topic. Let us study about atoms in our next topic. Till then, keep learning.